All right, today we are talking about lesson 1.3, real numbers and the number line. Okay, so for the first thing we're going to talk about here are square roots. Okay, this whole thing here is what we call a square root. A square root is made up of two parts. Okay, the symbol for square root is what we call the radical. And then whatever is inside of the square root or underneath of the square root is what we call the radicand. Okay, so if I ever use those two terms when talking about a square root, you know what I'm talking about. A perfect square is the square of an integer. And we're going to talk more about integers later in this lesson, but an integer is just a positive or a negative whole number. Okay? So for instance, 1 squared, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8, 64. 9 times 9, 81. 10 times 10 is 100. And we could keep going if we wanted to. These are what we consider to be the perfect squares. Okay? Because it is just a number times itself gives us these. So for instance, if we were to take the square root of 4, the opposite of that, the square root of 4 would be 2. Okay? So, one thing to remember is that if we take the square root, let's say we take the square root of 36, well, we have to ask ourselves, what times itself gives us 36? And you should think, well, 6 does. Okay? But there is also another answer here. Okay? 6 times 6 is 36, but negative 6 times negative 6 is also 36. So what we're going to do in front of the 6 is we are going to put a plus over a minus sign. We read that plus or minus 6. That would be our answer to the square root of 36. Example 1. Estimate the square root of 386 to the nearest whole number. Okay? So what I would do in this case is bring up your calculator. For square root, we are going to hit second x squared and type 386 and hit enter. Gives us 19.64. If we go back to the problem, it wants us to round to the nearest whole number. Okay? 19.64 is going to round up to 20. So my answer here would be 20. Okay? Rounding up to the nearest whole number. An inequality is a mathematical sentence that compares the values of two expressions using, and I'm going to put a colon there, okay, using the following signs, and we're going to write these down here. So we've got kind of an arrow pointing to the left, arrow pointing to the right, another to the left with a line under it, another to the right with a line under it. This symbol is less than. This symbol is more than or greater than. Next one is less than or equal to. And And the last one is more than or equal to. Okay? So anytime you see one of these symbols, it basically means that we are comparing two quantities. One quantity is less than or greater than another quantity. So for example, example 2 here. Compare root 17 and 4 1/3. Anytime that I ask you to compare or order two numbers, what we're going to do is change all of those numbers to decimals. It is much easier to compare two decimals than, say, a square root and a fraction. Okay? So, root 17. I'm going to go back to my calculator. I'm going to hit second x squared to bring up the square root. And we want the square root of 17. Hit enter. I get 4.123. So 4.123. For 4 1/3, we know our decimal is going to be 4 point something. 4 is our whole number here. So if we go over to our calculator, if we want to change a fraction to a decimal, we take top divided by bottom. 1 divided by 3. And that's just going to give us a repeating decimal of 0.3. So we have 4.3. Okay, so if we want to compare root 17 and 4 1/3, obviously 4.3 is bigger than 4.123. So we are going to compare them with the less than symbol. Root 17 is less than 4 1/3. Okay? Remember, our inequality symbol always points to the smaller value. Okay? Please take a few moments, pause the video, and please try letters A and B. Go ahead and do that now. All right, hopefully you've had a chance to try A and B. Please check your work as I go over these. Letter A, we want to compare root 129 and 11.52. So square root of 129, we've got to change that to a decimal. So I'm going to go back to my calculator. Second, x squared, 129. Hit enter. We get 11.357. Okay. Our second number, 11.52, is already in decimal form. Okay. So I'm going to rewrite these. Square root of 129 and 11.52. We can see comparing the 10th spot, okay, that 11.52 is bigger than 11.35. That means we're going to use the less than symbol. We are pointing towards the smaller value. So right there would be my answer. Letter B, it says order these values from least to greatest, so smallest to largest. So again, I want to take anything that is not a decimal and change it to a decimal. So square root of 4, you will notice 4 is one of our perfect squares. What times itself gives us 4? Well, 2 does. 0.4 is already in decimal form. Negative 2/3. We can do that in our calculator. 2 divided by 3 gives us 0.6 repeating. So negative 0.6 repeating. The square root of 2, we can do that in our calculator. Second, x squared, 2, enter, 1.414. And our last value, again, is already in decimal form. Okay? So, we want to put these in order from least to greatest, smallest to largest. So if you think about a number line and 0 in the middle, if I want to put these from least to greatest, I want to start with my biggest negative numbers first, work towards my smaller negative numbers, and then work towards my larger positive values. Okay? So my biggest negative value, in this case, I've got negative 0.6 and negative 1.5. So negative 1.5 is actually my smallest value in this case. And what I do as I write these, I like to cross them off so that I know I have already used them. So my next smallest is going to be the negative 2/3. Okay, so I'm going to cross that off. Now I'm into my positive values. I have 2.4 and 1.414. Okay, so my smallest is going to be the 0.4. So I can cross that off. Next one is going to be my root 2. And then lastly, my root 4. Now you will notice I am writing my original values, not the decimals that I changed them to. Okay? When we write our final answer, we want to use the original values. Okay? So the most basic part of the real number system is what we call natural numbers. I'm just using the number sign there. Okay? Sometimes you will see these be called the counting numbers. Okay? When we go to count things, if I were to count the number of students in a classroom, I go 1, 2, 3, 4, and so on. Okay? So the counting numbers are just 1, 2, 3, 4, dot, dot, dot. Okay? I could keep going forever. Notice, I do not have any negative numbers, and I did not include 0. Okay? On the outside of the natural numbers, we have what's called the whole numbers. Okay? The whole numbers are just the natural numbers, but we also include 0. Okay? That's the only difference between the two. On the outside of the whole numbers, we have the integers. Integers are positive and negative numbers, including 0. So negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on in both directions. Okay? So positive and negative whole numbers. On the outside of that, we have what's called rational numbers. Okay? You can see within that term rational, we see the root word ratio. Ratio is just another term for fraction. So basically, a rational number is any number that can be written as a fraction. So, for instance, 1/2, 0.45, 18%. Percents can be written as decimals or fractions. Negative 3/4, we can have negative fractions in there. Any of these things would be considered rational numbers. Same thing with everything inside of here. Everything inside of here is also what we call a rational number. Now, all of this stuff is related to one another, okay, as we work inside. Off to the side, we also have what's called irrational numbers. These numbers do not intertwine with these numbers. Okay, these are completely different types of numbers. So for instance, pi, 3.14159. The digits go on forever. They never repeat, okay, and they never end. So this is what we call an irrational number. The square root of 2, we typed that into our calculator earlier. It is a number, again, where the digits never repeat and they never end. Okay, another example, the negative square root of 11. Okay, negative square roots, if you type this into your calculator and the decimal goes on forever, it's irrational. Okay, if I write out a decimal, 8.1654329, and that goes on forever. Okay, that is an irrational number. Basically, irrational numbers are decimals that go on forever and never repeat. Everything else is what we call a rational number. So, you may get questions on the keystone asking you to classify different types of numbers. Okay? So for example 3, we have classified the square root of 12. In my calculator, I am going to type second square root of 12. We get 3.464101615. That decimal is going to go on forever. So that immediately tells us that it is an irrational number. Okay, and we can write that out. 3.464101615. Dot, dot, dot. Goes on forever. It's a 0. Example 4, root 16. If we simplify root 16, what number times itself gives us 16? That is 4. We could also do that in our calculator if you wanted to. Okay? So the number 4, we have to ask ourselves, was that a natural number? If I'm counting things, am I going to use that number? Yes. Okay? It is also all of the categories on the outside of that. So it is also a whole number. It is also an integer. And it is also a rational number. Okay? So for instance, if I were to give you this question on a test or a quiz, this would be a 4-point question. 1 point for each of those categories. Okay? So go ahead, pause the video, and please try letters C and D on your own. Alright, hopefully you had a chance to try C and D. Please follow along on your sheet. Make sure your answers match my answers up here. Okay? So letter C says classify 3.83. Could we write 3.83 as a fraction? Yeah, we could write that as 3 83/100ths. Okay, we can write that as a fraction. That means that it is rational. It is not a whole number or a natural number because it has a decimal. Same thing with integer. It has a decimal, so it is not an integer, okay, or a natural number or a whole number. So the only classification here is that it is a rational number. Lastly, letter D, -1. When we are counting things, we do not use negatives, so it is not a natural number, okay? It is not a whole number because whole numbers do not include negatives, but it is an integer. Now we have to ask ourselves, well, if it's an integer, is it also rational? Well, all integers are rational numbers. We could write, let's say, -6/6. That is equal to -1. So yes, this can be written as a fraction, so this is also rational. So in this case, we've got two answers here.